Good evening, ma'am.
Good evening, Mohammed. How are you?
Fine.
Great.
डेट लिखो डेट लिखो जी डेट लिखो
Good evening, Pranav. Good evening, Lasya.
Good evening, ma'am. Good evening, ma'am.
Good evening, Vijay.
Ma'am, is my voice
Yes.
audible?
Yes.
Ma'am, is my voice audible, ma'am?
हाँ, your voice is audible, beta.
Okay, ma'am.
Why have you joined twice, Lasya? You joined twice?
Ma'am, actually, my video is not working in my computer, ma'am. That's why I'm driving from the phone, ma'am, for video.
By joining twice, is that okay?
Yes, ma'am. Yesterday I managed in the
Okay.
bio class. The
Okay.
water in my phone will be ready, so you just audio the video and will keep aside.
Okay. So whatever we did yesterday about rational numbers, versus rational numbers versus irrational numbers. Okay, what are rationals? What are rationals? What happened, Mohammed? What happened?
Nothing, ma'am. Nothing.
Okay. Okay. So have you all understood all about rationals that we studied yesterday? That was all the introduction part. Okay. All numbers ranging from naturals, whole numbers, integers, rationals. Okay. They are all real numbers. They all collectively make real numbers. Okay. So we'll wait for 1 or 2 minutes so that if anyone else wants to join, they can join in and then we'll start. Okay, so today we'll be doing the properties. So today we'll do the properties of rational numbers, right? As you have done in your junior classes for whole numbers, integers. Okay. Closure property, commutative property, associative property, distributive property, all that. We'll do today over addition, over subtraction, multiplication, division, right? Yes, good evening, Ronit. Ronit is here. Okay.
Good evening, ma'am.
Good evening, Varshit. Good evening, who all have joined now, Ronit. Okay, so let's start. Moving ahead from the introduction of rational numbers. Okay, now we are coming to the properties part. Okay, was yesterday's, whatever we discussed yesterday, everything was clear?
Yes,
Any
ma'am.
doubts in yesterday's, whatever we did? Any doubt anywhere?
No, ma'am.
No, ma'am.
Anyone has any doubt? No. Okay, great. So we'll go ahead. Okay, we'll go to the properties now. I'm sharing the screen. 1 second, 1 second. Okay, this is your rational numbers. So, but we will now discuss the properties. So these properties, okay, properties on discuss all these. Integers, whole numbers you have already done in your junior classes, and now we are doing about rational numbers. Let's discuss now. So I'm taking a new page. Okay. So when we talk of properties, what sort of properties are there? What sort of properties are there? Just tell me the name of the properties are the same. Closure property, commutative property,
Associative
associative property. Okay,
Distributive property.
right? So properties are always the same. It's only thing that how does it stand for the different types of numbers. Okay. Okay. So first let's write the names of the properties. That's closure property. Then you have commutative. Then you have associative. Then you have distributive. Okay. Then you have reciprocals. Okay. Have you heard about reciprocals?
Yes, ma'am.
Have you heard any time? Reciprocal means what? Upside down.
Upside. Yes, ma'am.
Yes, ma'am.
No? If I write something in the form P by Q, then reciprocal of P by Q will be Q by
Q
Q.
by P.
Upside down. Yes. Okay. So that's upside down. Okay. So that's reciprocal. We'll study about this also. We have additive inverse also. We'll study all the properties now. Now starting from the first one. Let's first talk about closure property. Now, closure property. Okay. Now I say the sum when the sum of two rational numbers. If I take the sum of two rational numbers, say A and B. Okay. Closure property says that sum of two rational numbers is always a rational number. This is what the closure property says over addition. Okay. So over addition. Now in place of numbers. Now suppose A is 9. Okay. So I take A plus B. I want to prove this property, whether the answer is also a rational number or no. So I'll do A plus B 3 by 5 plus 6 by 9. What do I get when I add them? My denominator becomes 45. 5 into 9 is 45. Then this becomes 5 9 3 27 plus 9 5 is 30. Okay, so this is what I get, that is 57 by 45. So 57 by 47 is also a rational number. Is that?
Yes, ma'am.
So this is also a rational number. So that means, can we say that this property holds true for addition of rational numbers? Yes,
Yes, ma'am.
we can say. Okay, even if we have some rational number, say one number is some fraction and our other number is 0. So 0 added to any number will give us that same number only. And that is again rational. Okay, so that means this property holds true over addition for rational numbers, right? Okay, now coming to closer property over subtraction. Okay, we studied about addition first. Now let's see how does it work on subtractions. Now same, if we have a equals to 3 by 5 and b equals to 6 by 9. Now we'll write here closer property of subtraction. Okay, like this. This was for closer property for addition. We'll write here.
Ma'am, I have
Closer.
a doubt.
Yes, please ask.
Ma'am, when we add that 3 by 5 plus 6 by 9,
Huh.
in the answer, ma'am, in the numerator, it is given as 27 plus 30, ma'am. How
Huh.
we got that one, ma'am?
How
27
did
and
we
30.
get this? This is simple addition of rational numbers. You have
Yes,
studied in your junior class. How do you add the fractions? You take the LCM of the denominators and then you add,
yes, ma'am.
you
I'm
make
like,
the
I'm asking,
denominators equal.
yes, ma'am, I'm asking that
I
how we
got
got 27 and 30,
5
ma'am.
9s are 35 and 3 9s is 20. Huh. And 30 also we got the same way. 9 5s is 45 and 6 5s is 30. Understood now? This is a simple addition of rational
Yes,
numbers.
ma'am.
As you were doing in case of fractions. Okay, these are fractions only because numbers are natural here. I have not taken any negative number. Right? So this is closure property of subtraction now. Now, how does this closure property work over subtraction? We have seen on addition and now it's time for subtraction. Okay, now same we'll take A, let A be 3 by 5 and B be 6 by 9. 6 by 9 or we can take anything else, say 9 by 2. Okay, 9 by 2, which be different, we can try. It can be 6 by 9 also. Okay, now what will you do? Just subtract it the same way. Do the subtraction. You have studied in your junior classes. 3 by 5 minus 9 by 2. What do you get? There is nothing common between 3, 5, 2 and 5. So we'll multiply them. We take the LCM, that becomes 10. Then 5 2s is 10 and 3 2s is 6. Then 2 5s is 10 and 9 5s is 45. So our answer becomes 39 minus of 39 by 10. So that means this is also a rational number. If anything is in the form of P by Q and Q is not equal to 0, that means it's a rational number because it is in the form of P by Q and Q is not 0. Okay? And P and Q are integers. Okay. And suppose even if our one number becomes 0, no? Suppose if A minus 0, 3 by 5 minus 0, even if we subtract 0, then we won't get anything 0 subtracted from any number. You get the same number only. So this is again a rational only. Right? Okay. Understood this much?
Yes, ma'am.
So that means closure property holds true for subtraction also. Got it this much? Understood this?
Yes, ma'am.
Yes,
Closure
ma'am.
property over addition over subtraction. Right? Okay, now coming to the multiplication part. Closure property. Closure property of multiplication. Now, how does it work in case of multiplication? Now suppose if I have some integers, say -6/9 and 1/3. Okay. Now I have to multiply them. So A into B, how do you multiply the rational numbers? Do it. This part you have done in your junior classes. You just multiply the numerators, multiply the denominators. So you get -6 into 1 is -6, 9 into 3 is 27. So -6/27 is a rational number we can see here. It is in the form of P/Q. P and Q are both integers and Q is not equal to 0. So we can say this is a rational number. And what in case of if we have one number as 0? If suppose we have one number 0, we multiply this by 0, we get 0. 0 is again a rational number only. Why rational number? Because we can write 0 like.
Ma'am, we can write 0/1.
Yes, we can write 0/1 in the form of P/Q, and Q is not equal to 0. So this is also a rational number. Okay. So that means closure property holds true in case of multiplication also. All right. Okay, let's come to the division part now. Let's see how it works for division. I hope you are understanding this.
Yes, ma'am.
Yes, ma'am.
So closure property of division. So what happens in case of division? वो भी देख लेते हैं. Like this. So let A be any fraction 5/3. See, this is randomly I'm taking any rational number. Okay, you can take any rational number of your choice. Okay. Then what do we do? A divided by B we have to do, no? Like this. So A divide by B. Like this we do. And whatever we have in the denominator becomes the reciprocal.
Ma'am, you have to do reciprocal.
Yes, and the sign becomes multiply and this becomes the reciprocal of the denominator. And then we multiply as usual. 5 2s is 10, 5 3 1s is 3. So 10/3 is in the form of P/Q. PQ are both integers. Q is not equal to 0. So that is again a rational number. Okay. Now suppose if one number is 0, so what happens? Now if I write 5/3 and this becomes 0, so anything this number is not defined. Okay. This number is not defined. Anything divided by 0 is not an undefined number. So this means property does not hold true in case of division of rational numbers. All right. So it does not hold true, or we can say rational numbers are not closed under division. True means we use the word not closed. Closed means if the property is applicable, when we divide by 0, we get the number undefined. We use the word closed also. We use the word true also. We use the word holds also, closed also. Okay. In some books, it's written closed also. In some books, it's written the property holds true for division of rational numbers. In some books, it is written closure property rational numbers like this. Okay, these kind of words are written. All right, but the meaning is same. Okay.
Yes, ma'am.
Yes, ma'am.
Yes, children. Okay.
Yes.
So this was all about the closure property. So we did closure property over addition, over subtraction, over multiplication, over division. Okay, so we saw that closure property holds for everything except division. It holds true for addition, for subtraction, for multiplication, commutative property. Now the second property is commutative property. Now, same way here also we will discuss the addition, subtraction, multiplication and division part, okay, of rational numbers. Okay, let's talk about the addition first. Addition in, we'll say first, addition is commutative. Okay, now we will prove it. So that means addition is commutative. So how do we say that? We take any two rational numbers. Commutative means the order of the numbers a plus b. What does commutativity says? A plus b is equal to b plus a. If the numbers are added, it means the same. Okay, this is what the commutative property says. So let's take some two rational numbers. A is equal to 2 by 3, b equals to 7 by 8. Okay, then let's take a plus b. So 2 by 3 plus 7 by 8. What do we get? We get 24 here, and 3 8s are 2 8s are 16 plus 7. This is 21. So this becomes 37 by 24. Okay. Now if we add b plus a, so that is 7 by 8 plus 2 by 3. So we'll get the same thing. LCM is 24. We get 21 here. We get 16 this side. So the answer remains the same. Okay. So this says that the answers are same. That means the commutative property holds true for addition of rational numbers. Understood this much?
Yes,
Yes. Show thumbs up. Okay. Only Varshit is showing thumbs up. No one else understood?
no, we are just kept in the video.
Yes. If you are not able to unmute quickly, you can just show your thumbs up. Okay. So commutative property for subtraction now. Let's see how does it work for subtraction. Okay. Now here, A, let's take A 2 by 3, B 7 by 8, the same numbers. Okay. Now A minus B will be 2 minus 3, 2 by 3 minus 7 by 8. Do this, do the subtraction yourself. Do the subtraction yourself. Do this yourself and check whether you get the same answer. Check.
Ma'am, it will come minus 5 by 24 and 5 by 24.
Yes, children. So what's the answer?
Ma'am, minus 5 by 24 and 5 by 24.
Which one is minus 5? This one.
Ma'am, 2 by 3 minus 7 by 8 is minus 5.
And the other one is?
The other
5
one
by
is
20.
5 by 24.
So that means the both are not equal, right? Okay. So we can say that A
Yes, ma'am.
minus B is not equal to B minus B. That means the commutative property does not hold true in case of subtraction of rational numbers. Got it?
Yes, ma'am.
Okay. Anyone has a doubt here? Anyone has a doubt?
No, ma'am.
Then we'll go to commutative property. Commutative property for multiplication. Okay. Now let's take the same example 2 by 3 and B is and we are taking this now minus 7 by 8. Okay. Let's take this. Now just do the multiplication. Do A multiplied by B and B multiplied by A. Just check out yourself. Find the answer. Are they equal?
Ma'am, which two?
Ma'am, they are equal.
Yes, ma'am, they're equal.
Yes. So what you got?
Ma'am, minus 14 by 24.
What is the answer?
Ma'am,
Minus 14 by 24 in both cases.
yes,
Both the
ma'am.
answers are correct.
Yes, ma'am.
Right. Okay, so that is minus 14 by 24. So here also you have minus 14 by 24. So that means this property holds true. That means A multiplied by B is equal to B multiplied by A. Commutativity means the order, whatever order it is, the answer does not get affected. Okay? Right. What is this? Okay. Now moving to the division part. Commutativity for division. Okay, commutative property for division. Now taking the same examples 2 by 3 and B equals to 7 by 8. Let's do the division and check whether it holds true or not. Okay, so do the division yourself. 2 by 3 by 7 by 8. When you do the division, what happens? This denominator part will become reciprocal and it will have the multiply sign. I hope everyone knows this. Everyone knows this. How do we multiply the fractions? Divide the fractions?
Yes, ma'am.
Yes, ma'am.
Yes. Mohammed, you know that?
Yes, ma'am.
Yes. Do.
Ma'am, it comes 16 by 21 and 21 by 16.
Okay. So that means it's the reciprocal of that. So they are not equal. So this is 16 by 21 and this becomes 7 by 8 into 3 by 2. This is 21 by 16. So that means they are not equal. Right? So that
Yes,
means
ma'am.
the commutative property does not hold for division also in case of rational numbers. Understood this? Subtraction does
Yes,
not hold true, division does not hold true. Okay, in case of commutativity. In closure property, what did we find? We find that only division did not hold true. Okay? Yes?
Yes, ma'am.
Yes, ma'am.
Now coming to the associative property. Associative. Now, you know, in associative property, we take three numbers. Okay, we take three rational numbers because it is a group of three, A, B, and C. Okay. Property for rational numbers. Okay, let's do for associative property. For addition, first we'll see for addition. Okay, now what does this associative property says? It says that A plus B plus C is equal to A plus B plus C. That means if the odd numbers are added in any order, in any way it is grouped, they are equal. The answer comes out to be equal. All right, this is what the associative property says. Now we have to find out whether rational numbers stands true for this case or not. ओके अभी हमारा काम ये है टू फाइंड कि रैशनल नंबर्स के लिए ये ट्रू है कि नहीं है. ओके सो लेट्स टेक एन एग्जांपल फॉर दिस. लेट a is equal to 1 by 5 and second let a is equal to 1 by 5, b equals to minus 2 by 7 and c equals to 3 by 5. Okay, we have taken these three rational numbers. And we'll check out this. A plus B plus C is equal to, what do we get here? Now A is 1 by 5. Please do yourself now. In place of A, B and C, put the values of A, B and C. Okay, do it yourself. Do it yourself. First you will do this and then next will be A plus B plus C. This also you will do. Do yourself. Do yourself. Mohammed, do yourself. Don't look here.
Yes, ma'am, I'm doing.
Okay, what is the answer? What is the answer for the first one? A plus B in the bracket plus C. Yes, Mohammed, tell me what is 1 by 5 minus 2 by 7? Tell me, Mohammed.
Ma'am, I'm still doing.
Tell me this first. This much you must have done by now. Tell me what did you get for this bracket part? What is the LCM of 5 and 7?
Ma'am,
1 second. I am asking Mohammed. Mohammed, what is the LCM of 5 and 7? What is the LCM of 5 and 7? Mohammed, I'm asking you.
yes, ma'am.
What is the LCM of 5 and 7? Yes, what is the LCM of 5 and 7? Pranav, what is the LCM of 5 and 7?
35, ma'am.
Yes. Yes, Mohammed. What is the LCM of 5 and 7?
35.
So what made you think so much? You know how to find LCM?
Yes,
Now
ma'am.
tell me what do you get in the numerator here, Mohammed? Mohammed, tell me, I want the answer from you. What do you get in the numerator here? Now the LCM is 35. What do you get in the numerator here?
5.
Huh? 5?
5.
Okay. Should I write 5 here?
Yes, ma'am.
How can I write 5 here? See, I'm getting 35. How do you take the LCM and you do this subtraction? How do you do this subtraction, Mohammed? If I ask you to do this, how do you do this? 1 by 5 minus 2 by 7. कैसे करते हो ये? What do we do? Look here, we make the denominator same. Why same? Because there is nothing common in between them. So we multiply them both. Okay, 5 7s is 35. Now to make this 35, what will I multiply 5 with so that I get 35 here? I will multiply 5 with 7. मैं 5 को 7 से multiply करूंगी तभी मुझे यहाँ 35 मिलेगा.
Yes, ma'am.
मिलेगा ना?
Yes.
Okay. And the same number has to be multiplied in the numerator also.
Yes, ma'am.
So 7 ones is 7, right?
Yeah. Yes.
Now same way we will make the other number also. The denominator same, 735. 2 by 7 ko we want to make in terms of denominator 35. What will I multiply this with? 7 को किससे multiply करूंगी कि मुझे 35 मिल जाए यहाँ पर?
We have to multiply 7 2
With which number will I multiply?
7 5 7 5
7 5s are. So same number I will multiply in the numerator also. So 2 5s are now. Now I multiply as usual. Numerator with numerator 2 into 5 is what? 2 5s is what?
10.
10. Okay. So now I have 7 by 35 and 10 by 35. So when the denominator 7 by 35 and 10 by 35. Okay. So when the denominators are same, what do? We just subtract the numerators. Okay. Okay.
Come on.
So what do you get here? 7 minus 10. You get minus 3 by 35. Okay. You understood this?
Yes, ma'am.
So minus 3 by 35. Now you have solved this bracket part. Now you have to add this portion also. Plus 3 by 5. So now what do you get? Add this and give me the answer, Mohammed. Okay, so children, others pay attention here. So what have you got for this? The next one, A plus B plus C in the bracket. What have you got here? Yes, tell me the answer, others. Pranav, Ronid, Harsh, who's that?
Ma'am, we got 9 by 40.
Ma'am, doing ma'am.
Yeah.
Ma'am, we got 9 by 40.
How much is that?
Wait, ma'am. 9 by 40.
9 by 40. No, how do you get 9 by 40? Please check. You don't know how to add fractions. Mohammed, do this. Take the LCM of 35 and 5. Yes, Lasya, what did you get for this part? Do it. This is simple addition of the fractions, the rational number, simple addition. अभी तो मैंने यहाँ पे बताया आपको. How do you subtract the inside part? And whatever answer you get, then you have to add with the outer part. How much did you get, Varshit?
Ma'am, I got 18 by 35.
18 by 35. Okay. So now we see that both the answers are equal. Okay. That means the associative property holds true in case of addition. Right? Last year, try this. do this addition. Otherwise, I'll give you more sums of like this. This is very disappointing that you cannot do simple addition of rational numbers. Do it, Lasya. Okay. So coming over to subtraction part now. Okay. Associative property for subtraction. What's the time now? Your classes. Children, the class time is over. I have another class now. Okay, we'll continue in the next class, right?
Okay, ma'am.
Okay, so thank you for today. Please continue this and I'll give you some homework also. Check out after some time. I have another class. After that, I'll update the homework.
Okay, ma'am.
Okay, thank you for today. Bye-bye.
Bye, ma'am.
Bye, ma'am.
Bye, beta. Bye-bye. Please practice.